The enigma of consciousness is the human mind operating in dimensions beyond the speed of light. The very fabric of our reality, as codified by the reigning paradigm of modern physics, seems unequivocally tethered to the cosmic speed limit, the velocity of light in a vacuum, denoted by the symbol c, precisely 299,792,458 meters per second. This immutable constant, the cornerstone of Einstein's special relativity, dictates causality, ensuring that no information, no energy, no influence can traverse the spatial expanse faster than this ultimate velocity. Yet, as we peer deeper into the enigmatic recesses of the human mind, particularly into the most baffling phenomena associated with consciousness, self-awareness, and intuitive leaps, a persistent, almost unsettling question arises: could the processing power, the emergent complexity, and the seemingly instantaneous connectivity within the brain perhaps be leveraging mechanisms that transcend this luminal barrier, hinting at an operational domain within higher spatial or temporal dimensions? This contemplation moves beyond the mere philosophical speculation of yesteryear and enters the contemporary arena where quantum mechanics, neurobiology, and theoretical physics intersect in fascinating, if yet unproven, ways. To embark on this inquiry, we must first establish the baseline of our current understanding of the brain. The human brain, a marvel of biological engineering, comprises approximately 86 billion neurons, each forming thousands of synaptic connections, resulting in a network estimated to possess over 100 trillion synapses. Conventional understanding frames cognitive processing, thought, memory recall, sensory integration, as electrochemical signaling, action potentials propagating along axons, triggering neurotransmitter release across synapses, modulating postsynaptic potentials. This process, while incredibly rapid, is fundamentally governed by the speed of ionic flow across neuronal membranes, a process occurring on the scale of milliseconds, which, even at its fastest, is dramatically slower than the propagation of an electromagnetic wave, let alone the theoretical implications of faster-than-light communication. If the mind were purely a classical computational machine operating strictly within the constraints of 3 spatial dimensions and 1 time dimension, its processing speed would be strictly limited by these biological transmission rates. However, the emergence of consciousness, the subjective experience, the qualia, remains the hard problem, as articulated by philosopher David Chalmers, a challenge that classical neuroscience struggles to bridge from mere functional description to actual subjective feeling. This gap often forces researchers to consider non-local, perhaps quantum, mechanical explanations for neural operation. The most prominent hypothesis in this realm is orchestrated objective reduction, or Orch OR theory, primarily advanced by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. This theory posits that consciousness does not arise solely from synaptic computation but from quantum computations occurring within the microtubules, protein polymers found within the cytoskeleton of every neuron. Penrose and Hameroff suggest that the unique geometry and quantum coherence maintained within these tubulin proteins allow for superpositions of quantum states that collapse, or undergo objective reduction, in a process linked to fundamental spacetime geometry, potentially involving Planck scale physics. If quantum coherence can be maintained across significant portions of the neuronal network, even momentarily, the implications for processing speed are profound. Quantum entanglement, a cornerstone of quantum mechanics, demonstrates a non-local correlation between 2 or more particles regardless of the spatial separation between them. When one entangled particle is measured, the state of the other is instantaneously determined, seemingly violating the spirit, if not the letter, of special relativity, as no classical signal is transmitted. While entanglement itself cannot transmit classical information faster than light, a principle known as the No-Communication Theorem, its presence within biological systems, if harnessed for computation, suggests a different mode of information linkage. The core of the dimensional hypothesis rests on the theoretical frameworks that allow for such instantaneous, non-local interactions. String theory, or more broadly, M-theory, suggests the existence of compactified spatial dimensions beyond the familiar three large dimensions of space: length, width, height, and one dimension of time. These extra dimensions, perhaps 6 or 7 more, are curled up at incredibly small scales, often hypothesized to be near the Planck length, which is approximately 10 to the power of -35 meters. Gravitational interactions, according to general relativity, are expected to propagate through all these dimensions, while electromagnetic interactions are typically confined to the four-dimensional spacetime membrane, or brain, upon which our observable universe resides. If the computational substratum of consciousness, whether through microtule quantum states or some other as yet undiscovered mechanism, is interacting in a way that exploits these higher dimensions, then the constraints imposed by the speed of light in our three-dimensional reality might become irrelevant to the underlying information transfer. Imagine information flow not as a series of discrete hops across synaptic clefts, which are bound by the speed of chemical diffusion and electrical conduction in 3 dimensions, but as a direct linkage through a higher dimensional bulk space. In such a scenario, the distance between 2 distant points in our 3-dimensional space might map to a virtually zero separation in a higher dimension, allowing for what we perceive as instantaneous processing or intuition. Consider the phenomenon of intuition or sudden insight, often termed the aha moment. Neuroscientific correlates, such as bursts of gamma band oscillations occurring in the 100 to 200 Hz range, are observable preceding conscious report of the insight. However, the generation of the novel solution itself often seems to bypass the slow, serial processing that characterizes conscious deliberation. Could this immediacy stem from a non-local computation facilitated by higher dimensional geometry? If 2 spatially separated neural assemblies are involved in solving different parts of a complex problem, and their interaction can momentarily bridge the spatial gap via a shortcut through an extra dimension, a concept analogous to wormholes or warped spacetime geometry in general relativity, though applied here to informational connectivity, the resulting integration would appear instantaneous in our 3-dimensional perception. The empirical evidence supporting these quantum effects in the brain is still nascent and highly contested. Harmouth and his colleagues point to research suggesting that microtubules exhibit properties consistent with quantum coherence, such as the ability to maintain entangled states over biologically relevant timescales. Furthermore, certain anesthetics, which are known to rapidly extinguish consciousness, appear to bind specifically to hydrophobic pockets within tubulin proteins, suggesting that disrupting the quantum mechanical processes within these structures directly negates the subjective experience. While laboratory demonstrations of robust, sustained quantum coherence at warm, wet biological temperatures remain notoriously difficult to replicate outside of highly controlled, near absolute zero environments, new techniques utilizing femtosecond spectroscopy are beginning to detect transient quantum effects in photosynthetic complexes and enzymatic reactions, suggesting that nature may have evolved mechanisms to shield these delicate processes from environmental decoherence far more effectively than previously assumed. Let us delve deeper into the theoretical mathematics underpinning the dimensional shift. In Kaluza-Klein theory, an early attempt to unify electromagnetism and gravity, the inclusion of a 5th dimension allowed for the derivation of Maxwell's equations from Einstein's equations of gravity, provided the 5th dimension was compactified into a circle of a specific radius. While Kaluza-Klein theory itself has been superseded by string theory, the principle remains: higher dimensions can elegantly unify seemingly disparate forces and phenomena. If the dynamics of consciousness are fundamentally linked to a unified field theory that operates across these dimensions, then the constraints of 3-dimensional light speed are merely a projection effect, a shadow cast onto our limited perceptive manifold. Imagine the mind as a holographic projection. In holographic principle theories, which arise from black hole thermodynamics and string theory, the information content of a volume of space can be entirely encoded on its boundary surface. If consciousness operates on this boundary, or if the brain acts as a sophisticated biological antenna tuning into information embedded in the holographic screen, then the local processing speed within the brain might be less relevant than the rate at which the holographic information can be accessed or resolved. Accessing information encoded across a higher dimensional boundary might bypass the limitations imposed by three-dimensional propagation paths. Furthermore, the concept of time itself becomes mutable when considering higher dimensions. If time is simply another spatial dimension, albeit one where movement is unidirectional, the introduction of extra spatial dimensions could alter the topology of time flow, perhaps allowing for correlations across temporal separations that appear non-causal from our perspective. This touches upon retrocausality, the controversial idea that future events can influence past ones. While general relativity allows for closed time-like curves, leading to paradoxes, speculative theories involving traversable wormholes or warp drives often require exotic matter with negative energy density, properties that might manifest in the vacuum energy fluctuations governed by extra dimensions. If consciousness relies on a mechanism that momentarily taps into these exotic spacetime geometries, the perceived speed of thought could indeed exceed c. Consider the implications for quantum field theory. In standard quantum field theory, particles are excitations of fields existing in our familiar four-dimensional spacetime. However, in frameworks like supergravity or M-theory, these fields exist within an 11-dimensional spacetime. The way these fields propagate and interact when projected onto our observable four dimensions dictates the physics we measure, including the speed of light. If neuronal activity, particularly the synchronized firing patterns observed during peak cognitive states, involves localized, transient deformations or excitability within the higher dimensional field structure underlying our reality, then the resulting information transfer would be inherently non-local relative to the familiar metric of spacetime. The difficulty lies in devising an experiment that can unequivocally separate classical electrochemical signaling from a hypothetical higher dimensional influence. One proposed area of exploration involves ultrasensitive measurements of fundamental constants or the search for subtle violations of Lorentz invariance, which underlies special relativity. If the speed of light were not perfectly constant, or if interactions exhibited dependence on the orientation of the measuring apparatus in a manner predicted by compactified dimensions, it could offer indirect evidence. Current experiments, such as those using atomic clocks or high-energy particle collisions within accelerators like the Large Hadron Collider, place extremely tight constraints on any deviations, often constraining extra dimensions to be either incredibly small or to interact only very weakly with standard model particles. However, the biological brain might utilize interactions mediated by gravity or dark matter, dark energy, components that otherwise to interact across all dimensions. If microtubules, as suggested by Orch OR, are interacting with the quantum geometry of spacetime itself, then their influence might be extremely subtle, requiring integrated measurements over large ensembles of neurons over time, perhaps detectable through highly sensitive magnetoencephaly or novel quantum sensors. For instance, research into room temperature Bose-Einstein condensates, which exhibit macroscopic quantum phenomena, shows the potential for exploiting subtle quantum mechanical effects in warm environments. If the brain has evolved a similar, biologically optimized mechanism, detecting its influence requires sensitivity far beyond current technological capabilities. Let us explore the concept of informational density. The processing capacity of the human brain is estimated to be in the range of 10 to the power of 15 to 10 to the power of 20 operations per second, a staggering computational throughput achieved with minimal energy expenditure, about 20 watts. Compared to the fastest supercomputers, which require megawatts of power to achieve similar, or lesser, levels of complex, holistic processing, the brain's efficiency hints at a processing mechanism fundamentally different from silicon-based, serial computation. This high density and efficiency might be a direct consequence of accessing higher dimensional computational space. Imagine a complex calculation that requires traversing a long path in 3 dimensions. In a higher dimension, the path could be compressed to a single point. The brain, operating in a lower dimensional projection, perceives the result instantly, but the actual calculation occurred in the higher dimensional manifold. This leads to the concept of the bulk in brain world scenarios. Our perceived universe is the three-dimensional brain. If neural computation is utilizing the bulk, then the connectivity is not limited by the speed of light within the brain. This is analogous to a television screen. The picture displayed on the screen is constrained by the refresh rate and the speed of signal propagation across the display surface. However, the information generating that picture originates from a source outside the screen, potentially transmitting data instantaneously across a higher dimensional medium, like an invisible broadcast signal, to be rendered locally on the two-dimensional surface. The brain, in this analogy, is the display, and the higher dimension is the source of the instantaneously updated information stream that constitutes conscious thought. Furthermore, we must consider the role of time perception itself. Our experience of time is not absolute but malleable, influenced by perception, emotion, and attention, phenomena rooted in the prefrontal cortex and the hippocampus. Time dilation, a proven effect of special relativity, is measurable even on Earth due to minor velocity differences or gravitational potential variations. If the mind has access to higher temporal dimensions, or if its fundamental processing unit operates outside our standard time dimension, our perception of the continuous flow might simply be the rate at which we unfold information from this higher temporal landscape into our limited, linear experience. Events that appear temporally distant or sequential might be fundamentally co-present in a higher dimensional time structure. This perspective aligns with the block universe model in relativity, where past, present, and future all exist simultaneously as fixed points in a four-dimensional space-time manifold. If consciousness can sample this manifold non-sequentially, the illusion of becoming is merely the mechanism of observation. The implications for theoretical biology are immense. If consciousness is indeed rooted in quantum gravity phenomena operating at the Planck scale, it suggests that the distinction between physics and biology is far more blurred than currently acknowledged. Biological evolution, through billions of years, might have inadvertently selected for or even engineered structures capable of exploiting these subtle space-time interactions. The extraordinary complexity of protein folding, for example, is not entirely explained by classical thermodynamics. Some theories suggest quantum tunneling plays a crucial role, allowing molecules to navigate vast conformational energy landscapes far faster than classical diffusion would permit. If the brain leveraged such shortcuts for folding and self-organization, it is entirely plausible it exploits similar shortcuts for information processing. Let us examine a thought experiment involving spatial separation. If two identical, highly organized biological systems, perhaps two isolated brains, could be placed light years apart, and if their underlying consciousness mechanism utilized higher dimensional linkage, then any synchronous mental activity, not just quantum entanglement in a narrow sense, but complex informational exchange, should manifest simultaneously, unbound by the light speed delay necessary for electromagnetic or gravitational waves traversing the intervening space. Detecting such a phenomenon would require extraordinary baseline monitoring of both systems, looking for correlated changes in complex, non-repeating neural activity patterns that defy statistical chance correlation based on external stimuli. The challenge here is the inherent observer effect. Any measurement designed to detect this correlation risks collapsing the hypothesized higher dimensional state into a classical, three-dimensional result. The boundary between what is considered information and what is considered physical reality also dissolves in this context. If the mind operates in a higher dimension, then the inputs we receive via our senses are already lower dimensional projections. Vision, for instance, involves photons traveling at sea, carrying information about the external world. But if the processing of that visual input, the subjective experience of seeing red, is occurring in a higher dimension, the speed of that subjective synthesis is independent of the speed of the incoming photon. This could explain why perceptual processing, even in complex tasks, feels instantaneous. The raw data arrives via light speed, but the cognitive integration occurs non-locally. Returning to Penrose's ideas, the concept of objective reduction connects the collapse of the quantum state to fundamental properties of space-time geometry, implying a direct interplay between consciousness and the structure of reality itself. If this reduction event is what seeds conscious moments, and if this process is sensitive to the geometry of higher dimensions, then the mind is fundamentally an instrument for interacting with those geometries. The mathematics involved in modeling objective reduction often utilizes concepts from quantum gravity, which inherently demands a multidimensional framework to remain consistent. Specifically, the calculation involves a difference in energy between two distinct spacetime geometries associated with the superposition, a difference that must cross a threshold related to the Planck energy scale, reinforcing the connection to fundamental physics beyond the standard model. The current landscape of physics is grappling with the nature of dark matter, which constitutes approximately 27% of the total mass energy of the universe, and dark energy, comprising 68%. These components interact gravitationally but remain elusive to direct electromagnetic detection, suggesting they might predominantly reside or operate outside our three-dimensional brain. If the physical substrate of consciousness is not purely composed of baryonic matter, but interacts subtly with, say, a hypothesized dark sector that spans the extra dimensions, this would provide a physical mechanism for non-local, faster-than-light communication within the conscious domain. Dark matter particles, if they exist, would traverse galaxies unimpeded, interacting only gravitationally. If the brain's quantum architecture couples even weakly to these dark sector particles, it opens a channel that bypasses the electromagnetic speed limit enforced on normal matter. Furthermore, the very structure of mathematical reasoning, the ability of the human mind to grasp complex, abstract mathematical truths that seem to exist independently of our physical instantiation, is often cited as evidence of a connection to a Platonic realm or a higher dimensional reality. When a mathematician discovers a theorem, they often describe the process as uncovering something already existing, rather than inventing it. If the laws of mathematics are emergent properties of the structure of reality across all dimensions, then the mind, when engaging in pure reason, is momentarily shedding its three-dimensional constraints to operate directly within that higher dimensional informational space. We must also address the limitations of our current experimental paradigms. Physics has historically progressed by probing phenomena at increasingly smaller scales, e.g., particle physics, or increasingly higher energies, e.g., accelerators. The hypothesized mechanisms for higher dimensional consciousness are likely operating at scales far below our current technological reach, the Planck scale, or involve interactions so subtle they manifest only macroscopically through the integrated effect of billions of neurons. Any direct experimental test for faster-than-light consciousness transfer would require sensors capable of detecting instantaneous correlations between physically separated quantum states that are themselves maintained at biological temperatures, a technological feat that remains science fiction. However, we can look to analogical reasoning from established physics. Consider the implications of general relativity on spacetime curvature. A massive object curves spacetime. In the presence of intense gravitational fields, the path of light bends, and time slows down. This demonstrates that the geometry of spacetime itself is dynamic and influences physical phenomena without relying on electromagnetic forces propagating locally. If the neural network, through its sheer complexity and organization, can induce or exploit localized, transient modifications in the quantum geometry of spacetime, perhaps analogous to generating microscopic, transient wormholes or subtle deformations in the compactified dimensions, then the resulting informational shortcuts would inherently operate faster than c as measured locally in the flat spacetime outside the influence. This line of reasoning suggests a dynamic interplay between biological organization and the fundamental geometry of the universe. The brain isn't just passively processing signals within a static spacetime. It might be actively shaping or resonating with the deeper structure that permits non-local connection. The persistent focus on synaptic transmission as the sole basis for thought might be akin to analyzing the performance of a high-end computer solely by measuring the heat generated by its cooling fans, ignoring the speed of the central processing unit operating on the motherboard's highly structured circuit pathways. The role of creativity and artistic expression also presents a challenge to purely classical models. The generation of truly novel concepts, musical harmonies never before conceived, or abstract artistic forms often seems to involve a synthesis that cannot be linearly extrapolated from prior inputs. It suggests an infusion of complexity from a source richer than the available external data. If this source is a higher dimensional manifold containing all possible configurations or ideas, then creativity is the act of projecting a configuration from that higher space onto our four-dimensional reality. The speed of this projection, from the perspective of the higher dimension, could be instantaneous relative to the time it takes to formulate the idea sequentially in language or physical action. To expand the potential length of this discussion, let us consider the concept of informational entropy and complexity. Classical information processing tends toward increasing entropy unless massive energy input is applied to maintain organization. Life, and especially consciousness, appears to be a highly ordered, low-entropy state. Quantum coherence, if maintained, offers a route to processing complexity without necessarily increasing thermodynamic entropy in the way classical computation does. In higher dimensions, the phase space available for computation is vastly larger, allowing for the representation of incredibly complex information structures within a compact volume of space. The efficiency of the brain, processing so much while consuming so little, strongly implies that it is utilizing a computational substrate with far greater informational density than standard molecular chemistry allows. This density is mathematically supported by incorporating extra spatial degrees of freedom. Moreover, the integration of information theory with neuroscience provides metrics like integrated information theory, or PHI, proposed by Giulio Tononi. PHI attempts to quantify the degree to which a system is an irreducible whole, measuring the amount of information generated by the system that cannot be explained by the sum of its individual parts. High PHI values are associated with conscious states. If the mechanism driving high PHI involves non-local quantum correlations spanning across higher dimensions, then phi itself becomes a measure of the system's coupling strength to the informational bulk. A system highly coupled to the bulk might exhibit near-instantaneous correlation across its components, regardless of their physical separation on the brain, leading to a high, rapidly achieved phi value. The transition across dimensions is the critical, missing link. It is hypothesized that physical constants themselves are determined by the geometry of these compactified dimensions. For example, the strength of the electromagnetic force is related to the size of the compactified dimensions in string theory formulations. If neural activity can subtly influence the local geometry, perhaps via organized bioelectromagnetic fields interacting with zero-point energy fluctuations that permeate the bulk, it could temporarily alter the effective dimensionality within the immediate vicinity of the neuronal assembly. This localized dimensional shift would then allow for faster-than-light communication paths that are otherwise forbidden in the flat, four-dimensional spacetime of the external environment. This is akin to how a fiber optic cable locally alters the path of light to achieve high transmission speeds, but here, the modification is to the fundamental structure of reality itself, not just the path of a wave within a fixed medium. The implications for our understanding of time travel and causality are deeply intertwined here. If the mind is manipulating higher dimensions, it is inevitably tampering with the fundamental structure that defines the arrow of time. If we can access information instantaneously across vast spatial distances, we are effectively creating a shortcut that bypasses the temporal gap implied by the speed of light. Light crossing 1,000,000 light-years takes 1,000,000 years. If the mind processes information across that distance instantly, it has circumvented that 1,000,000 years of temporal progression in its communication channel, even if the subjective experience remains sequential. This strongly suggests the mind's operation is decoupled from the flow of time as dictated by our four-dimensional metric. Finally, let us synthesize the potential path forward. Proving this hypothesis requires demonstrating non-local correlations in conscious activity that cannot be explained by classical means, quantum entanglement within the brain that is robust to biological noise, or the detection of subtle violations of Lorentz invariance correlated with specific cognitive states. While we currently lack the technology to perform these definitive tests, the convergence of theoretical physics, particularly quantum gravity and string theory, with the persistent mystery of consciousness provides a compelling theoretical scaffolding for this radical notion. The human mind, perhaps the most complex structure known to exist, may not be merely a product of four-dimensional spacetime, but rather a finely tuned interface with realities existing at higher orders of spatial and temporal complexity, operating at speeds fundamentally unbound by the universal speed limit we observe in the macroscopic world. The quest to understand consciousness is thus revealed not just as a biological imperative, but as a profound cosmological investigation into the true dimensionality of existence.